In this episode,
we have good people and bad people.
There's a bit of a danger side to it.
The tail should never wag the dog.
Quite a lot of people say they can do it in an hour.
Garbage in, garbage out.
See Simon's face then.
Hi and welcome back to another episode of the award-winning Homeowners Q&A Podcast. I'm your host Mars, and today we're diving into one of the most critical and most misunderstood aspects of heat pump design, heat loss calculations. Joining me to break this down are four brilliant guests. We've got Rich Cartwright from Heat Engineer, Cadd from UK Alternative Energy, Simon Murray from Octopus Heating, and Mario Dodić from the HVAC Education Club. Welcome, gentlemen. Before we get started, we'd like to thank our sponsor, E.ON Next. E.ON Next has been helping UK homeowners make the switch to renewable energy and sustainable heating for years, offering advice, trusted installations, and ongoing support to help households. Whether you're exploring air source heat pumps, looking to optimize your home's efficiency, or just beginning your renewable journey, E.ON Next team are there to make the process simple, transparent, and tailored to your home. A big thank you once again to E.ON Next for supporting this podcast and for helping drive the UK's renewable heating revolution. So we're going to start this episode. We're going to try and push some paper. We're going to try and sell some books, Mario. You actually contributed a chapter to our last book called Heat Loss Calculations and Heat Pump Sizing. Could you just walk us through what a heat loss calculation is?
What I can explain always, like your house is like a bucket. So you have bucket full of water, but this bucket is leaking. So your house is analogy with this bucket. So your house is leaking. What is the first and most important thing? That you need to have temperature difference. So, for example, if you want 20 degrees in your house and outdoor is 20 degrees, you don't have heat loss. So it is the same. So first and most important thing is temperature difference. How we are going at lower temperatures, so plus 10, 0 or minus 5, let's say in Scotland, then heat loss is higher. So higher temperature difference, higher heat loss. This is the first and most important thing. Second part is materials. So depending if your house is well insulated or not so good, then we have some measurements of these materials, how good or bad it is. And second part is surface. We need to have surface through which we are losing heat. For example, if you have, let's say, first floor and ground floor, you don't have heat loss from your ground to the floor because there is no outer air. So we need to have outer air, generally speaking. For example, your external wall with windows, this is your main thing. And as the name suggests, calculation, this is calculation, and we need to go as close to the truth as possible. We have some assumptions, and we need to check what will be on the coldest day in your region. Then we have some different regions and different outdoor temperatures, and we need to check what is heat loss on your coldest day. Additional thing in the UK, it's a thing called defrost, where you have high humidity in the air, and then you need to add slightly more capacity of your heat pump, but this is maybe another topic, to not go in detail. Just to add one more thing, this is so-called fabric heat loss, so through materials, and we have ventilation heat loss through air changes. So if you have some chimney or some openings and you're opening windows, again, we have some assumptions how to calculate ventilation heat loss.
So Rich, we spoke last week because you're going to be coming through to actually visit us next week. You'll be doing a heat loss for us on our property, which is something that we sorely do need. When we had a quick chat last week, you actually mentioned to me that there's multiple different ways of actually doing a heat loss calculation. Could you just walk us through those particular methods, just so viewers can actually get a bit of an overview as to what they can expect when somebody comes to do a heat loss calc for them?
Regarding the approach you take on it, so there are various sort of tools out there to collect that data. One of the things that we're quite proud of, there's essentially 4 ways to do the survey. So either if you've got the engineering drawings, you can upload the drawings, you can start measuring, scale the drawing, start measuring it, and those dimensions automatically populate into the survey. So that's great if you've got an engineering drawing. The other approaches, which we've had for many years now, is using the actual app. So if you're on site, an engineer will have an app with their laser tool and populating the dimensions, either it's from Bluetooth from the laser tool directly into the app. So again, so you're on site, you're populating dimensions directly from either reading the laser tool measurer or the Bluetooth is actually sending those dimensions into the app. The other approach is to use a desktop approach. So you might actually just have a laptop. So just typing the dimensions in there. And again, building materials. And then the fourth approach is using something called Magic Plan. There's a few providers out there now are actually incorporating Magic Plan. And obviously we're one of them, where you walk around with a an iPad Pro or an iPhone Pro model, and it uses the LiDAR lens. So in the back, you just sort of see there here. So there's a LiDAR lens just on this one here, and that allows you to capture each room in 3D. It does recognize furniture. You can turn on and off furniture. But the most important factor which we want to extract is the dimension. So window areas, floor areas, external wall lengths, internal wall lengths, and volume as well. And once you can get that data from the 3D model, we can then import that into the software. Again, big time saver. So essentially, that's what I'm trying to sort of summarize is, yes, there are multiple ways to do a site survey.
So Dan, I assume you've done a few heat loss calcs in your time. Which of the methods do you favor?
Historically, I've gone around, like Rich was saying, with a laser measure, taking down dimensions and using that kind of method. More recently, with the new sort of stuff I'm using with HeatGeek, it's more the LiDAR in the on the software, and it's using that to map a room as we go around. Even when you're doing that, I sort of find that sometimes you do have to sort of fall back to, checking measurements every now and again. If it doesn't always pick the rooms up ever so precisely, especially if it's a difficult room. And so sometimes it is handy also to have your tape measure in your laser measure anyway.
So I assume even with the LiDAR, even though you're scanning out the room, which I'm hopefully, going to get a first-hand experience next week, but I assume you still then have to put values in for things like windows, because it can't obviously understand whether it's double glazed, triple glazed, single glazed. I assume that you still got to manually input data. Is that correct?
Yes. Yeah. You still have to input your U values. You need to feed it that information in order for it to make the calculations. Yeah.
Simon, Dan mentioned U values. Could you just, again, for the benefit of homeowners, just explain what a U value is and just how subjective they are from the surveyor's point of view?
Very subjective. So a U value is a value given to an item that kind of dictates the rate of which energy will pass through that item. Heat losses at the moment are subjective, whether they're done using a pen or paper, a piece of software, or machine learning. There's no way. If you get two of the same bricks in a wall, if you were to put those into a lab condition, the chances are that they will have a different, might be only ever so slightly, but a different rate of energy transfer through essentially what's being marketed as the same thing. There is a running theme that's really interesting. So I've heard a lot of people say this in the marketplace, installers saying that, and I think Adam Chapman calls it like fat in a heat loss survey, but that we're over egging heat losses by around 30%. And it was interesting. So I was sitting with a manufacturer this week and looking at their data of what they've been doing with their heat pumps, and it's leading down the same path. And it comes back. So you asked a question about U values. Is the value is taken at a laboratory condition at a point in time, a bit like the fuel emissions thing. Like, this car gets so many miles to the gallon. This piece of material has this thermal property, which is equated to a U value. Does it? We don't know.
This isn't just another book about heat pumps. The Ultimate Guide to Heat Pumps brings together the collective voice of over 35 contributors, engineers, designers, troubleshooters, and homeowners with more than 7,500 installations and 585 years of combined experience. It's no-nonsense, practical advice to help you get it done first time. Available now, link in the description. So Mario, I think the biggest issue from what Simon just identified there is that heat losses are quite subjective, and we'll get onto a case very, very shortly. That heat loss is ultimately going to give the installer / the homeowner the insights as to what size heat pump they're going to get for that property. So if somebody gets a heat loss horribly wrong, I just assume that then they'll get the wrong sized heat pump, and that's going to lead to a whole world of different pain for that homeowner. Would that be a correct statement?
Yes and no. The main thing is if you have experience, then you can, let's say we are all trying to get as close to the truth as possible. But then you are monitoring your installations, you have some experience, and then you have overall picture. What will be the heat loss of this property? As Simon said, usually it's 20 to 30%, let's say, oversizing just because of these assumptions. But then if you add defrost in this calculation, then you need an additional maybe 20% for defrost. You're fine. So you're good with this calculation. But I think most important thing is how experienced are you with the heat pump manufacturer? because there are different manufacturers with different datas. And then you have usually 5-6 different models, so like 5, 7, 9 kilowatt, 12, but they are using the same compressor for two or three models. So for example, if we say your heat loss is, let's say 6 kilowatt, we have unit of 7 and 9, but both units, they have the same minimum output. This is what always concerns me, minimum output, because we said if -5 is outdoor, for example, you have 10 kilowatt heat loss. But then if it's +10, you have less than 4 kilowatt, something like this. And then if your heat pump can modulate low enough, you don't have a problem with oversizing. This is why it is important to have, let's say, deep knowledge of all of these things, because then you will know to match heat loss, assumptions, okay, air changes. We will go slightly conservative, but then we know that our manufacturer of heat pump can manage that. So you need to have whole picture. It's really hard if you design a system and someone else will install or sell the heat pump. This is, from my experience, it's really hard job. The best way is to have everything under your own control. And from experience and monitoring and discussions like this, we are all learning. So I talk with Rich. Rich is behind the software, so he has really good knowledge. Then he said to me, okay, you need to have this and that assumption. And then we are really close to the truth.
So Rich, how closely do you work with installers and try to guide them to get these, as Mario puts, assumptions kind of correct? Because there clearly are a lot of assumptions that are being made, and it does lead to a lot of kind of different values. You know, you can get different installers that go and, you know, survey the same property and they get different outcomes, and that's purely based, I'm guessing, on their assumptions.
Yeah, I think it's to do with the collection process, the collection of the data. So if they're on site and they're having a conversation, one engineer might have a conversation with a customer. They might know about what's actually in the walls, so they might have an idea of what's, if there's any insulation at all. But another engineer might just make an assumption like, might not even have a conversation with a customer. Or the third engineer will go up and sit in the loft and have a look down to see in the cavity to see what kind of level of insulation, if it's sagged or anything, or if it's had any cavity injection marks into the wall. That's just one example of, like, you know, okay, how it could pan out of actually how to collect that data. And I think even if we just start looking, what Simon mentioned about, like, you know, how confident we can be with the U value is, let's start off with exactly, like, what is the thickness of that red brick? What's the thickness of the cavity? Can we really, you know, check to see what is actually in that wall? And getting your tape measure out, opening up a window, opening up the door, measuring that whole width of the door to make sure we got the full width of the actual profile of the external wall. Those steps certainly do help, rather than saying, oh, look on your EPC. On your EPC, it's got this, you know, building materials. So that's like, you know, just please don't ever do that. You know, see Simon's face then. Going the extra mile, collecting the data on building materials is super important. That's just one aspect. The other aspect is that we kind of typically are, how old is this room? You'll have different rooms built in most of the time a house is built in the same, they're all built at the same time, right? All built in 2001, whatever. But you might have an extension, you know, kind of like 20 years later. So that room needs to be specified as a new build, essentially, and it will use different air change rates for that particular room. Again, you're going the extra mile. You're not just assuming it is all built in the same year, because the default air change rates will affect that. Another factor which you can do as well is input a pulse air test or blower door test as well. So again, an extra mile of fine tuning the air change rates. So we talked about using, you know, we said the word ventilation, but air change rates, as in air change rates per hour. Yes, we could argue that they've been over-egged. You know, we're over-assumption. There have been lots of over-assumption that has been made over the years. Now we can actually plug in a blower door test result and pulse air test, which will then fine tune each room individually, look at the external envelope and tweak the air change rates for that particular room. So again, it's going the extra mile of collecting that data and how much effort you put into measure the property from that perspective. There's a further conversation as well about, you know, what kind of room temperatures do you want? Typically, realistically, you should be designing all the rooms to 21, apart from bathrooms at 22. Certainly if the property is over, 2006. And certain customers might want warmer rooms, you know, might have an elderly couple in there. They want rooms at 23 degrees. Again, it's another sort of consideration that you need to sort of like to start to make. So, you know, an engineer might have considered that. They might have had a conversation with the elderly couple. The third engineer might not have done that. Depending on what the engineer, how much effort they put in to collect that data, really does impact on the variation of the output of the heat loss. So that's just to get started anyway. We've got other topics to talk about as well. But a bit of an introduction to that one anyway.
So Dan, from what Rich just described there, it's an incredibly intricate process that an installer has to go through. And I had a bit of a disconcerting conversation with quite a reputable installer recently who said that it takes him 10 to 15 minutes to do a heat loss calc, and he's typically only kind of 15% out, which I found really, really disturbing. So if a homeowner is watching this and they are going to maybe have a heat loss calculation done, how long should it typically take for that installer to kind of get through their property?
Before I go out to a house, I'll always have a conversation with the customer on the phone and discuss, will I be able to get around the house? Is there access? So that you do a bit of prep before you go, and discuss what the customer's looking for. You get a bit of an idea. So when you get there, you're not, going in blind as such, because if you haven't done that, and then you go in, you then have to start building a picture once you get there. And even if you've had that conversation, you still need to, start forming a relationship with the customer and discussing, what their expectations are, and build a bit of background for yourself before you start looking around. Depending on the size of the house, obviously that can affect the length of a survey. But I would say roughly an hour and a half to a couple of hours for me personally. I know quite a lot of people say they can do it in an hour, but I don't think I've really ever been to one that I can get done in an hour, because like Rich was saying, you're trying to find all these little bits of information. Can you get into the cavity, and are there points on the outside where you can see that the insulation has been injected, and all that sort of thing takes time, but it's worth investing that time, so allowing the installer the time they need. One of the worst things when you're in a house and they're starting to look at their watch and thinking, I've got to go out in 10 minutes, can you hurry it up a bit? And not really, no, I need to collect the data that I need, otherwise it's going to be out.
I don't get the industry and their push towards we need to make heat loss a quick thing. Is your journey through installing a heat pump, from when you first speak to a client to when you sign off and get the bus grant, is building blocks. And that heat loss survey is the foundation for the entire install. Why are we making that speedy? Make it good. Do it properly. Put the effort into getting that bit as accurate as you can. And then everything that comes after that stands a chance of actually working and being good, and not being like Mars's system.
If you miss heat loss, then you are missing flow rates, pipe sizing, emitters, everything else. I think the main part here, Mars, as we are speaking for homeowners, how much homeowner also wants to spend. For example, maybe you will even not get this job. So if you just want to go to check, then you cannot spend whole day, because you're spending your money, your time, especially if you are installer, tools and so on. But then if you agree, okay, we will have really deep insight, like Rich said. So you can have 5 assumptions or 20. If you have 20, then you are closer to the truth, as I mentioned before. So you need to speak with the people to understand if they have children or no. And you need to spend a lot of time just to explaining this, to try to hear from the people. Then if you are done, after that, you will have maybe another call or another visit to check the pipes and so on. So it's a whole process, but you are investing 10 or 15,000. So I think it's worth to spend a couple of hundreds more on proper heat loss and proper experienced guy who will take you through this journey.
Architects don't do drawings for free. Heating engineers shouldn't do designs for free.
Yeah, good point. It's actually quite interesting, because when I actually went through this book, we had independent contributors, all writing chapters. Even when they were writing on something completely different, they actually said, you got to start with the heat loss. You got to get the heat loss calculation done right at the outset, because that's the linchpin, as Mario said, of the entire project. So if you get that wrong, it's going to have a knock-on effect for everything else. So Rich, if there is a homeowner that's considering this, should they trust the installer to do that, or should they outsource that heat loss calculation to somebody that specializes in nothing more than heat losses? Then they can just take that information, give it to that particular installer and say, this is my heat loss, please work towards this.
I think that's a really interesting proposal. It's exactly how I used to work as a consultant many years ago. There's a bit of a danger side to it, because if the homeowner wants to take that risk, and the reason there is a risk involved, here's a heat loss. You can give this to any installer and hopefully they should accept it. Now, I remember back in the days, there was a couple of installers that were aware of me, and I said, look, okay, these installers trust my heat loss and they accept it, and you can choose whichever you want to use. But the problem is if they end up going to an installer and said, I've got a heat loss already, the installer and it does happen. Like, I'm sorry, I don't trust this. I don't know who this person is. I need to do my own. I'm MCS registered. I have to do it appropriate. It's on my, indemnity insurance. Because it all comes back down to insurance at the end of the day. Again, it totally depends on the relationship. If they have an existing relationship with a third-party surveying company, because if they do, then it works perfectly, and there are plenty of independent surveyor engineers out there that will do it and make a good living out of it. And they do, to be fair, they are specialists as well, so if there needs to be more kind of like promotion about that, to say to the homeowners, use an independent surveyor engineer. However, make sure that they have a good relationship with the surrounding, postcode area of installers that you might be reaching out to, and run it that way.
My experience from Croatia, you have certified engineer, must know this job. And for 10 kilowatt house, they put 30 kilowatt. So even software, which we are talking about, that garbage in, garbage out. If you don't define window and you have a hole in the wall, then you will have 30 kilowatt heat loss. But then you need experience and common sense to say, okay, something is wrong here. Here, I want everything by my own. I don't trust most of the people in that area.
If you've got any questions about heat pumps, then you need to join the Renewable Heating Hub forums. You can connect with other homeowners, share experiences, and get advice on heat pumps and renewables. Sign up today and be a part of the conversation. Link in the description. This is something that we get asked so much, and we actually had a post that actually came on the forums this week from a guy called George. They have shared their experience with their heat pump surveys. They have a 1930s 4-bedroom home, and they had 3 heat loss calculations done, and they were all over the place. So Heat Geek, or a Heat Geek installer, calculated the heat loss at 8.45. Octopus did the same property at 10.27. And British Gas did it at 7.69. My math isn't great, but that's kind of like a 30%-ish swing from highest to lowest. And that potentially means the difference between a 7 and a 10 kilowatt heat pump. So in this kind of case, Simon, if a homeowner is in this kind of situation, what do they do? Who do they, they might like all 3 installers, but which of the options do they actually go with, given, they're kind of all over the radar?
So this is how messed up the market is. I had a client recently that I had to walk away from the job because I went to this client, they're having building work done. They were getting plans drawn up. They didn't have plans. And I went and spent a few hours with them, 2-hour visits talking about exactly the home, the future project, the resisting solar thermal, what we were doing. Anyway, they had 4 quotes from 4 different companies, ranging from a 12 kilowatt down to a 5 kilowatt, which the house was a 5 kilowatt Valent aerotherm. The problem was, at the time they had those 4 quotes, they didn't have a window schedule from the builder, and they didn't have accurate volumetric plans from the architect. They had some plans. They didn't have the plans they needed to do an accurate design. So you had 4 companies out there, including some big national ones, that were designing based on, we think it's going to be this. That, I can't run my business on that. No way. Right? That's not what I'm giving clients. I'm giving clients an educated design based on real numbers, really understanding the fabric that's going into their property. And this client actually thought that I was pulling fast one, because they're like, why can't you give me a quote? Because everyone else is giving me a quote. So I can't give you a quote because I don't know the materials are for your home. So I can't size the heat pump, I can't size the pipework, and I can't design the system properly. I won't cut corners, and I won't do what everyone else in the market is doing just to get sales. There's this big thing of machine learning, and it's still assumption based. Until you get heat load, which is coming, while we're still working on heat loss, everything's an assumption. You get people that are really good at working with those assumptions, and then you get people that are not so good. Personally, when I'm doing a heat loss, I use a pen and paper, I use tape measure, I use a laser, because if anything on the technology dies and I'm in a client's house, my battery on my phone goes, no offense to heat engineer, because I think it's great what you do. I have to know the long way of doing it, because if anything fails technology-wise, I can still do it, because I've said it on here before. The heating system is the dog, the heat pump's the towel should never wag the dog. You cannot get that heating system right unless you understand the building.
So Dan, if there is a homeowner that is stuck in the same situation as George, or kind of similar scenario to Simon, where they get, heat loss ranging from 5 to 12 kilowatts, and they like all 3 installers, all 3 seem to be credible, what do they do? Who do they choose? I mean, it seems to be an impossible situation to actually select the right guy.
Where would you go with that? I mean, it's not even like you pick the middle one, is it? Because you can't. it could go any way.
And it's an impossible situation because you're dealing here with three national companies. I mean, we're not even looking at three local installers. We're talking about three reputable, established kind of brands.
I mean, I suppose if two are reasonably similar and one's way further out, then you're going to be looking at the two that are a bit closer together.
A lot of installers don't display their inputs, in these reports. And I think that's what's really important. So if the homeowner at least has got exposure to those full report, like obviously we do in our reports, but if they can see the building materials, so go to the pages like, oh, actually they put like, I've got single glazed windows. I haven't got single glazed windows in that room, so there might be some really obvious things a homeowner can do to look at that. So yes, they might not going to go through all the calculation side of things, and they won't be aware of air change rates and all that kind of stuff. But simple things like design temperatures. Are they happy with that design temperature? Oh, one company used 18. Oh, they use 21. Looking at the building materials, do you feel like they've got the correct structure of the wall? Do you think they've got the correct windows? Oh, so that company put 200 mil loft insulation. I've got 300 mil loft insulation. This company did that. So there are some like due diligence checks that a homeowner can do, but they need access to the inputs that were made.
I would look at system design as well, what they're selling you. And I don't mean system design as in this pipe's this size. And I mean, are they putting a buff tank in? Are they putting separation in? Are they using third-party controls? Are they doing different room temperatures in different rooms? Is my kitchen open plan in my living room and they're telling me the kitchen's 18 degrees and the living room's 21? These are telltale signs of a company that does not know what they are doing. If they can't quantify those reasons, it's very difficult from a pure heat loss survey to see if a company's good or bad. If you're living in a 3-bedroom house and someone says, you need a 12 kilowatt heat pump, I would just ask why. Maybe you do, but maybe you don't. Like, that seems excessively big. But you need to understand why they've stated that size heat pump. The other thing is heat pumps come in all different forms as well. So when we say 12 kilowatt, it might not be 12 kilowatt at -3 or -2. It might have a 7 kilowatt output. You need to ask the questions of the person selling you this kit, because there could be a perfectly good reason that's the right kit for you, but it probably isn't. And these are the telltale signs.
Some companies will charge for a survey and others don't. I think companies that charge a fee for the survey are going to be more willing to share that information. Some companies, whether they're good or bad, they might come and do a free survey, give a proposal, and then if the homeowner then says, well, can you give me a bit more information on that? They might not want to give that information until, an order's been placed. Whereas a company that's, charged £250 or £300 or whatever people are charging, that customer's paid for that survey, so really should have access to that information.
So Mario, if you have got a heat loss calculation done, that heat loss calculation should typically get paired up with an emitter guide. So basically the recommendation for whether RADs do need to be upgraded. Is that correct?
Yes and no. So generally you are designing kilowatts or watts in some room, and then if you miss, so for example, if you say this room is 1000 watt, and in reality it's 500 watt, it's a big difference, because your radiator might be good enough. Also depending on the flow temperature, because you will have also here difference. You have guidelines, but maybe someone will say, okay, let's go as lowest as possible, and some other installer will say, okay, maybe you don't need to spend a couple of thousands for changing radiators. Maybe we can do it next winter or something like that. But it's still a process, as Simon said, and everyone, it's still a process. You need to understand people. Someone will say, yeah, I have a nice house, I cannot change radiators, I will go with the same and go with higher flow temperature. Okay, I'm fine, I will pay something more. This is decision, because homeowner will decide on that. The most important thing is communication. So how you communicate with your customer, how he's communicating with you, as Dan mentioned. So it's not the same. Also, if someone will say, oh, give me a quote, if it's for free, I will give assumption, and always in assumption I will have probably 30% more. I will say, okay, it's 10 kilowatts. Maybe it's 7, but I don't know. If you will place the order, then I will go in detail and say, okay, we will save you money and go with 7.
We went to a client once that was calling us because they were in a 2-bedroom house and they had a 7 kilowatt heat pump installed, and they were cold, and they had massive solar array batteries, and their bills were over £500 a month in winter. Okay, so everything was screaming there's a problem here. Did a heat loss. The heat loss was 12 kilowatts. Okay, it was a stone cottage, loads of glass, There's reasons for it for being that big. So what had happened is the company had done a heat loss that wasn't accurate, so they massively undersized it. But even the heat pump that was supplied had 22 mil primaries on it. So it was like a 7 kilowatt heat pump with 22 mil primaries. You're potentially throttling straight away. I raised this, so we were brought in to do forensic analysis of this system. We worked with the original company that put it in, and we worked with the manufacturer as well. The manufacturer did not want to know. I told them the problems of the system. I did an 18-page document which highlighted everything wrong with the build, through to the fabric, through to the undersizing of the heat pump, the heating system being wrong. And the manufacturer's like, we rely on the installer to do the heat loss. We are not interested. Our responsibility stops at the buffer. The installer, this was their first heat pump. They'd gone to that manufacturer for help and support, and they'd had none. And the manufacturer's like, look, we've done hundreds of installs across Europe. We know what we're doing. We're not interested in what you've got to say. And actually, they contributed to that installer making that mistake.
Manufacturer today cannot take handle of all of these things. Maybe they will, but today, that's why you will say also buffers and so on, because they don't have anything with your radiator. Generally speaking, they don't have. Another point is that they need to support you as an installer, as a homeowner. This is another story. But generally speaking, they are delivering only the box. But this box is only small part of the system. If your pipework or your, let's say, body is wrong, then your heart is nothing. This is why, let's say, installer is the first most important thing, or engineer who is doing your house. Another thing is manufacturer and connection with installer and manufacturer. And how good is this education? For example, when I used to work for manufacturer, I was focusing more like all of these things. And then small part of the training was, okay, this is commissioning. But not anything can be done without specific manufacturer. So if you are doing heat loss, pipe sizing, emitters, doesn't matter what is the heat pump. This is what I was trying to teach my installers. Take care of all of this. Whatever you put inside will be fine. If you are good enough, you will know.
But that is a massive problem, though. And the case that Simon just described, we've also got very small primaries that actually run from our heat pump into the actual property itself. I appreciate that this isn't necessarily a heat loss calculation conversation, but it is something that, the actual box that's been put out there, if it's designed to deliver 10 kilowatts of heat, but the pipework restricts it so it can only deliver 7, you're going to fail, right? I mean, so who does that onus fall on? I appreciate it's the installer that should do that, but at the same time, the manufacturer should be giving them the guidance to say, for the love of God, please do not put anything less than, 32, 35, whatever it is, primaries onto our systems.
Agree, but this is, again, coming back to installer and manufacturer. But manufacturer, it's not like some corporation. It's still the people who are working there. Maybe you have Simon working for manufacturer, or maybe you have someone who just started, who doesn't care anything about all of this. It is the same, like in every business. You have good people and bad people. Why I am into this thing? Because I realized how this expensive heat pump can work really good and really bad. And it's like, okay, someone is paying, for example, new build. You are spending hundreds of thousands of euros, pounds, millions, and then your system is really, really bad. And then I feel for the people, because after food, heating is the most important thing. And this is why, for me, it's more also like personal thing, not only business thing, because you need to feel these people. They need to be warm in the winter. I can help. How much can I help to these people?
You raised a good point about new builds as well. I was speaking to Clayton from EDF Heat Pumps the other day, and he quite rightly said, like, the mandate for new builds is 55-degree flow temperature. Why? Crazy. Doesn't need to be that.
Heat loss is so low that you can easily get the start designing for 45 flow temp. Yeah, completely agree with that. It shouldn't be for 55.
Rich, do you want to wrap up the episode for us? So give us one piece of advice that you would give to homeowners that actually are sitting and having to review their actual heat loss calcs. What advice would you give them?
I think I mentioned it before, in the sense of like checking that they're happy with the inputs. And I think this is actually getting the inputs, and the report is actually crucial. And I've seen so many heat loss calcs, that they only provide the outputs. Don't accept that. Ask for the inputs, because that's the only way you can really double check that you're happy with what they've put in. It's like any software, any kind of industry. If the inputs are wrong, then the outputs are blatantly going to be wrong as well. So pick up the phone, email your installer and say, look, please, thanks very much for the results, but I want to do a little bit of due diligence. Please, can I just see what building materials used, temperatures you used? Can I see the inputs, please? That's clean, easy, and quite a simple request to ask from a homeowner to installer to get.
If you've got any questions about heat pumps, then you need to join the Renewable Heating Hub forums. You can connect with other homeowners, share experiences, and get advice on heat pumps and renewables. Sign up today and be a part of the conversation. Link in the description. So that wraps up another episode of the Homeowners Q&A Podcast. A massive thank you to Rich, Dan, Simon, and Mario for sharing their time and expertise today, and to our sponsor Eon Next for supporting this conversation and helping us keep homeowners well informed. And a quick shout out to Peter Black, who's always one of the first ones to tune in and watch our podcast. Thanks for your support. If you enjoyed this episode, please like, subscribe, and drop us a comment below. And don't forget to share it with anyone that's planning a heat pump installation. Until next time, stay warm, stay green, stay tuned. Goodbye.